Hello friends, I Pankaj Dumka welcomes you all to this particular course on graph theory, and this is lecture 2. In this lecture, we will be learning about the basic or let's say major classification of graphs. And apart from that, we will also be learning about certain important terminologies related to graphs, which will be very helpful to understand graphs. So, without any further delay, let us start. So, the main classification of graphs is this. That is, the first one is called as directed graph, and the second one is called as undirected graph. Now, what is a directed graph? So first we will be talking about directed graph. Consider this graph A, B, C. These are what? These are vertices and they are connected by edges. This you have seen in previous video. What is the difference? Now the difference lies here. In this case, these edges are basically having arrows on it, and these edges are called as, though it is an edge, but as arrows are present, so they are also called as arcs. So basically, what is a directed graph? A directed graph is a graph in which the edge of the graph are assigned an ordered pair. So here, if this is edge 1 E1, this is edge E2, this is edge E3. So this edge E1 will be assigned this ordered pair. This is what E1. So it is B comma A. So here this is telling me that this B is my initial vertex and A is the final or terminal vertex. So the edge or the arc E1 will be starting at A and ending at, starting at B and ending at A. So this is the direction attached to this particular vertex. And due to the presence of these directions, this particular type of graph or graphs which are having directed edges are called as directed graphs. Okay. Now, what is undirected graph? So any graph in which we don't have directions attached to edges, they are called as undirected graph. So if I draw this graph, let's say this is the graph A, B, C, and D. These are vertices and they are connected via edges. And here, in this particular case, the edges don't have any direction. Now, what is the difference? The difference is, if I can say I want to start from A, I want to go to B, or if I want to uh, come back from B to A, then I can do it in the same on the same edge. That means I can go from A to B, I can come from B to A. Doesn't matter. It is permitted in this particular type of graph, that is undirected. Whereas if I am interested in coming from A to B, sorry, this is C. So C to B via edge E2, then I am permitted to do this. Whereas if I want to come back from B to C via edge E2, then this is not permitted. So therefore, this directional sense gives the name directed graph, and these are undirected graphs where we can move from A to B, B to A, and it is all permitted. So these are basically two major classification of graphs, that is directed and undirected. Now, once you know this, then there are certain terminologies you should understand. The first one is adjacent vertex. Sometimes also called as connected vertices. So, what is an adjacent vertex? So, to understand it, consider a graph A, B, C, and D. And let us focus on this vertex A. Okay. Now, this vertex A is connected to how many vertices? It is connected to D, it is connected to C, and it is also connected to B. So, therefore, the vertices which are connected via an edge, they will be called as adjacent vertices. So, if there is an edge between two vertices, then we will be saying that those two vertices are adjacent. So, here A is adjacent to D, A is adjacent to C, and A is adjacent to B. Consider B. Now, B is connected to A as well as C. So, therefore, B and A are adjacent, B and C are adjacent. So, therefore, adjacent vertex or vertices are those vertices which are connected via an edge. Okay. Now, once you know or understand the meaning of adjacent vertex, let us try to understand what is a loop. Loop is also sometimes called as self loop. Consider this graph. Here, everything is fine except this edge. So, if this edge is E1, this is E2, this is E3, and this is E4, then this edge E4 is called as a loop. That means an edge for which the starting and the ending vertex, initial and terminal vertices are same. So, for edge E4, the starting is A, ending or terminal is A. So, as the starting and ending vertex for this particular edge is same, therefore, this edge is called as a loop or self loop. Okay, now there is another term called as isolated vertex. What is an isolated vertex? Isolated vertex. Consider this graph. Now, this is vertex A, vertex B, C, D, and E. You can observe in this particular graph, and one more thing, graphs are normally represented as G. So, G is basically collection of two sets, one is vertex and another one is edge. This is how graphs are represented. So, now coming back to this graph, so here in this graph, if you notice, all the vertices A, B, C, and E, they are connected. That means there is an edge between one vertex and the another. Whereas there is one vertex, that is this one, D, which is not connected to any of the other vertices in the graph. And this particular vertex, which is not joined to any other vertex or not connected to any other vertex in the graph via an edge, is called as an isolated vertex. Okay. Now, once you know what an isolated vertex is, then you should understand about parallel edge also. What is in parallel edge, or what are parallel edges? Consider this graph. In this particular graph, you will be able to see that between C and B, this is vertex B, this is vertex C. So in between these two vertices, there are two edges, let's say E1 and E2, and this is E4 and this is E5. So between C and B, E1 and E2 are two edges. So they will be called as parallel edge. So what is a parallel edge? A parallel edge is, or two edges or more than two edges are called as parallel edges if their starting and the ending vertex, starting vertex and terminal vertex, initial vertex and terminal vertex is same. So for edge E2, let's say, and this is E1, and this is start and this is end. If I consider this C as start, then for both E1 and E2, C is the starting vertex and this B is the ending or terminal vertex. So for both the edges, the starting vertex and the terminal vertex is same. Therefore, they are called as parallel edges. So remember, two or more edges are called as parallel edges if their initial and terminal vertices are same. Now you have to be very cautious uh, uh, while you are in a directed graph and you want to search for parallel edge, then you have to be very cautious. For example, this is one graph and this is another graph. What is the difference? Now look, if you look this graph G1, then there are two edges which are between two vertices A and B. Here, as well as in G2, these two edges are in between A and B. So can we say this E1 and E2 or this E1 prime and E2 prime as parallel edge? In this particular graph, AB, as both the graphs are directed, and if I consider G1, then in this graph, this E1 is starting at A and ending at B, whereas E2 is starting at B and ending at A. As this is what? As this is a directed graph. So for both the edges, the starting and the terminal vertex are different. So here we cannot say that these two are, so what we can say is that these two are not parallel edges. Whereas in this particular graph, both E1 prime and E2 prime have the starting vertex A and their terminal vertex is B. So as the starting and terminal vertices are same for these two graphs, then we can say that this particular combination, that is E1 prime and E2 prime, is making an parallel edge. And the last terminology which you should understand is called as adjacent edges. So this was your fourth, and the fifth one is adjacent edges. So what are adjacent edges? So here I'm drawing one graph. So let's say it is A, this is B, this is C, and this is D. Now, if this is your E1, this is E3, this is E5, E6, E4, and E2, then what can you say about E1 and E3? What is common in E1 and E3? This vertex is common. Likewise, what is common in E3 and E5? Again, vertex A is common. If you look E5 and E4, what is common in between E5 and E4? This vertex B is common. And if you look this vertex E4 and E2, what is common? So in if you look edges E4 and E2, this vertex C is common. So therefore, adjacent edges are those edges which are having common vertex. So common vertex is something which you have to search for in case of adjacent edges. But wait, there is one more important thing. If you are searching for adjacent edges, then please do remember that those edges should not be parallel edges. Because in case of parallel edges also, you will be having common vertices. But both ending as well as starting vertex will be common in case of parallel edge. For example, E6 is parallel to E5. So therefore, they will not be considered as adjacent edges. For adjacent edges, there should be only one common vertex. So I hope you have understood the basic definition or the types of graphs, that is directed and undirected. Then you have understood now about adjacent vertex, that means vertices which are connected by edges. Loops, that means those edges whose starting and ending vertex is same. Isolated vertex, that is the vertex which is not at all connected to any of other vertices in the graph. And parallel edges, those edges which are having one common vertex. But the thing is, parallel edges are not considered in case of adjacent edges. So in this graph, till this point only, in the next lecture, we will be discussing about further classifications of graphs, and then we will be moving to higher understanding of graph with the help of degree and size, order, etc. So in this lecture, till this point only, thank you very much for watching it.